Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of the magnetism of the forces and fields unit. We will do the forces and fields, and we started the magnetism part in the previous lesson. Today we do the next part of this, and with the advance of the magnetic field and lines we do the two rules today, and both are called the left hand rules, number one and number two. So this is number three rule two, and that rule we do in the next lesson. So basically we're talking about the left hand rules. This we already know, like some intuition you all know that what are those we do with our hands, left hand, which is called the left hand rule of the magnetism, where we can find that where's the magnetic field goes, where the force goes, where's the direction of the current goes. So that's all thing we have to know from here. So before starting this, we are doing two types of things, that if we have the straight wire and if we have the coiled wire. So that's two experiments doing by the Austers. Austers work is doing like in 90s or the 18s, and that's what we just know in this, like not in very detail, just we have to know that these are the two words of the Austers. So what are those words? So first one is if the electric current flows in a straight line. If we have a straight wire, if we have a straight wire like this is a wire. We have a straight wire. So when we do the electron flow in this, what type of magnetic field we get? So in that case, we get the magnetic field which are a set circular pattern around the wire. So the magnetic field like goes like this. This is the battery attached to this, and when the electron flow goes in, you can see this goes like circular pattern, and they follow the specific direction in this. So in this, they goes like this, and they move like this, the round and round between the that wire. They do the circular pattern. For the electrical flows is coiled wire. So the coiled wire is also known as the solenoid. The solenoid is type of the thing which has the like a coiled wire in this. The coil wire wrap on that any kind of thing, any kind of insulator. The coiled wire wrapped in this, and when we get the magnetic field approximately straight within the solenoid. So you can see this behaves like a magnet. So if the electron flow goes like this. So if this is south direction, if it is a north direction, and this is your coiled wire, you can see from here that the magnetic lines originate from the north. You can see they originate from the north, and they goes inside to the south. So that's all thing the magnet do in this thing. So basically we're telling that the straight within the solenoid, that when they go to center of the solenoid, you can see this goes like center. This is center of the solenoid. You can see that lines are straight. Lines are straight. In this there's a like kind of a circular pattern. In this you can see there's straight line in the center because of the coil wire. So that's the two experiments you have to know. So for the straight wire and for the coil wire, that's the all thing. This is for the Austrians. So before starting with the left hand rules of the magnetism, we have to know that in this we use some terms. So what that terms? Basically, there are two terms only. So there are two hand rules, first one and the second one. So if we have some negative type of thing, if you have some negative charges, so you use the left hand. Left hand to show that where's the magnetic field, where's the current, and where's the direction of the magnetic force. For the positive charges, we have to use the right hand. So that's the two rule, left and right hand. Both are the same, both are like of the some slightly different in both. But for the negative charge, we use always left hands, and for the positive charges, we always use the right hands. Two things more, this is the vector kind of thing, and if it goes into the page, it's directed in the direction towards the page. It enters page at a 90-degree angle. So when we made with the hand that rule, so it's looking like this. So look like this thing. So when we do like this, so if not like this, when we do the other third rule, you can see there's something those when we see that where's the then go flow those, when you put the finger on your paper, you can see that there's something it goes into the page, or something goes out of the page. So into the page and out of the page happens when we do these things. So for this we use some symbols. So for into the page, we use the cross symbol. If like the paper and they go into your finger goes into the page. So this means that we could use a cross in that case. And If the out of the page, writing away from the page, it is axis the page at 90 degree. So it is out of the page, and out of page is denoted by the dot. So it's out of the page. So they all are like 90-degree angles. That's why they mentioned that this is 90 angle. They go towards the page at the 90-degree angle, and they exit the page at the 90 degree. So that's the two cases you have to know this. So for first one, we have the left hand rule. Number one. So it's an easy rule, and what we have to see that first hand rule is used for the straight length of wire. If you have a straight length of wire, if you have a straight wire and you want to know that where the lateral flow goes, where the magnetic field goes, where that two things goes, and for this you can use your left hand rule for that, for the straight wire. You can hold the wire with your left hand like this, fingers like coiled into the wire, and the thumb goes up to the north direction. So the thumb represents the direction of the lateral flow. So that thumb represents your lateral flow in that case. And your curled fingers show your direction of the magnetic field around the wire. So that magnetic field shows you around the wire. So that's the thing you have to know, that that curled wire goes magnetic field and that thumb shows the lateral flow. This is all we have to see in this too. This is a conductor wire. So this is the left hand rule. Straight length of wire, for straight length of wire. For left hand and two, this is for the coiled wire, like for the cylindrical shape, like for the solenoids we can say. So second left hand is used for solenoids, tightly wrapped coiled wire. If we wrap coiled wire into insulator, any insulator, so that's the thing we have to use in this. This is the same thing, but there's a reverse of this now. So the left hand grabs the coil by pointing the fingers in the direction of the lateral flow. Now your fingers, which are folding like this, which are coiled like this, they show the lateral flow. In that case, your thumb shows the lateral flow, but in that case, your coiled fingers show the lateral flows. And your thumb will indicate a direction of magnetic field inside a solenoid. So inside the solenoid, they show your magnetic field like this. So your thumb in that case shows the magnetic field line, and your wire, which you call this, shows the direction of the lateral flow. Like this is a reverse of that. So left hand will just straight lateral flow. Thumb, magnetic field curled wire. For two, for second, your coil wire show lateral flow and the thumb shows a magnetic field. So it can also be thought of the pointing towards the magnetic north hand of the solenoid. You can say that this is the north hand of the solenoid. So this is the north hand of solenoid. You can also see from that perspective too. So that's the hand rule to other, like a not very, they are slightly different, but just the opposite thing. Everything stayed the same in that case. When with the third rule, that was the different one. And third, we have a two thirds in this 3A, 3B. So let's conclude this lesson with an example. So we have to find the direction of the magnetic fields, which is to the right of the wire. If to the right of the wire means they goes to right. So if we handle the wire towards the right. So I'll find the magnetic field strength only. So if it grabs that lateral, and this is thumb goes down now because lateral flow goes then. So your thumb goes down and you coil that wire like this. So this significance that this goes like this. Your magnetic field goes like this. So this is your magnetic field. So what you can see, the magnetic fields when it goes into the paper. It goes touch to the paper and then it comes out. This means magnetic field goes into the page. So in first case, your magnetic field into the page. For the second one, so above the wire, you can see from above the wire. So you can hold that thing from above the wire and your thumb point is towards this, that thing, and you from the above the wire. So you can see that can goes like this. You can see that above the wire when it goes down, you can see that you can come above, you can come out from the wire. When you come from the outer wire from here, you can see they go out. First the into, and from the above, for you above you want to see, so from the above they come out, so this means they come out of the page. So this means your magnetic fields in that case is out of the page. That's the thing. For the last one, around the wire. Current is coming out of the page or from the wire. So what you see that this is a circle and the electron is over there, and they give the hint that current is coming out of the page from the wire. So current goes out of the page, so they do something like this. They coil like this over there. And what's the flow? They follow the clockwise flow. Goes they go from out of the page. So for that thing, in that case, if it is in clockwise, which is around the wire. In that both cases, you use the left hand rules. If you want, you can mention this. This we have to use a thinking that how's the goes. It goes clockwise around the wire. So that's how the left hand rule works. Number one and number two. We do number three in the next lesson, and we learn about how to use. We do equations too now. So yeah, this is all for this lesson. Learning by survey, EduVibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.